find the zeros. Okay, now we're used to doing that because we've been doing that right now. F of x is equal to 2x squared plus 9x plus 3. So if I could factor it, I could set each of the factors equal to 0 to get my zeros. But 2 times 3 is 6. I can't add factors of 6 to get 9 because it's 6 and 1 would give me 7 and 3 and 2 would give me 5. So that's not going to work. So my go-to thing is to use the quadratic formula. Oops. A is equal to 2, B is equal to 9, and C is equal to 3. Now watch me tonight. I'm tired, so I'll make some mistakes. I need you to catch them. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that would be a negative 9 plus or minus the square root of 9 squared minus 4 times 2 times 3 all over 2 times 2. Now, I think everybody can plug in and get those. It's after this step that people seem to be having some problems. This one on the test is not supposed to be tricky for you. 9 times 9 is 81, and 4 times 2 is 8 times 3 is 24 over 4. Now, you don't want to subtract incorrectly. I did one today, and I subtracted the craziest two things and got a crazy, crazy number. So if you do that, you know, there's not much you can do when you subtract incorrectly. Let's see what we get here. 81 minus 24, I think, is 57. Somebody double check me. Is that right?
Yeah.
Okay, so now 57 doesn't have anything you can use to multiply it by, I don't think. Let's see, 3. Will 3 go into 57? It might. 27,
Yeah.
19. But 3 and 19 are both prime. So there's no way you can break that down. So those are your answers. Now, I noticed that on the last test, people put this in as an answer, just in that form, and the author counted it wrong because they wanted you to split it up. So keep that in mind, that you may have to write this as this. Now, I'll go in and catch it. I went in and corrected those and gave you credit if you put plus or minus. But for some of those, they want you to split those up into 2. So watch the directions on it because it should tell you. Now, I think everybody can do that number 13. Any questions on it?
When we put the answer into the actual program, we don't have to put the plus sign for the first answer, right? Like negative 9 plus the square root of 57?
Yes, if you don't put that plus sign in there, it's 9 times the square root of 57.
Okay.
So yes, you do
okay.
plus in there. Now, if the 9
Okay.
had been positive, I wouldn't have to put a plus in front of the 9. But in between there, yes. And actually, those are conjugates, guys. We just talked about that. See how those are conjugates? Negative 9 plus the square root of 7 and negative 9 minus the square root of 57. Those are conjugates. So they come in conjugate pairs just like that, 1 plus and 1 minus between them. Okay, any other questions? All right. Let's do this number 14. It says find the vertex. And the problem is f of x equals 4x squared plus 24x minus 3. There's 2 ways you can find the vertex. You can put it in your calculator and graph it and find it, and I'm going to show you how to do that. I don't know which way you prefer. Sometimes it's easier to just do it without doing it on the calculator, doing it the other way. So
I can't see the problem. I was trying to write it down.
Let's see. 4x squared plus 24x minus 3. Can you see it now?
Yes, plus
Okay.
24x minus 3. Okay, yes.
Okay, I'm going to grab my calculator and put it in my calculator and see what I get. See, my vertex is way down there somewhere. So I can still do it. I can still find it without even seeing the bottom of it. I don't have to change it. I can change it by changing my window to, it's going to be way down there, I think. So let's try y minimum of negative, let's see, 50 maybe, and count by fives. Y max is 10 is good. Let's count by fives. Let's see if we can get it now. See if we can actually see the bottom of it. Yep. You can actually see the bottom of it, but it wouldn't have mattered. We could have done it without it. Now, what you want to do is this little parabola, it looks like that. You want to mark a mark on this side and mark one on the other side of the vertex. Here's your vertex right here. That vertex is a minimum. So I'm doing second and calculate. We've done this several times. Notice that we haven't used many of these, but we've used minimum and maximum and 0. You have to decide if that's a minimum or a maximum for that vertex. And it's a minimum because it's at the bottom. So you go down to number 3, or you can just click on number 3 and it'll do it. Then it's going to ask you for the left bound. So you're looking for something over here on the left side. So I'm going to arrow over, and you can actually see the cursor on this graph. You can see it bouncing around there. And when I get to the left side somewhere, I'm going to hit enter, puts a little triangle up there. It's a marker. Then I'm going to move over to the right side of the vertex and put another one. It puts another marker up there. Then I'm going to hit it one more time, and it will tell me what my vertex is. My vertex is -3, -39. So that's using the calculator to do that. Now, to get your graph back to the normal graph, you can go zoom, and number 6 will always get you back to a standard graph if you forget how to do that.
I have a question really quick. Okay, when you did the window, which one did we change? I mean, I know how to do it. I just keep forgetting about the window.
On the window,
Mm-hmm.
hang on a second. Let me get it to do it. It's still thinking about where it is. Well, it's hung up. Hang on a second. There we go. My X-min is -10. And see, when I looked at my picture on this, I can see the edges of it here. See those edges? So it's not the X-axis that's the problem. It's coming down, and it's the Y-axis.
Right.
And I know it's way below 10, but I don't know how far below it is without doing some work. So it's the Y I'm trying to figure out. So I go down to Y minimum, and I change that number to something really low, like I think I used -50. You could use whatever you want to. And if you don't want to count by ones, whoops, I used the wrong negative. -50. And if you count by twos, let's say, then it'll show you the bottom of your graph. And it's a minimum, so you go to second and calculate. You want a minimum. So you mark it over here on the left side, and you can see that little cursor, it's blinking. If I stop, you can see it blinking. See it blinking? Make sure it's on the left side. Then make it go over on the right side of it. Same thing you do with a 0 or any value that you want. And it will give you the minimum value is -3, -39. Give you the minimum value is -3. I'm sorry?
That just answers so many questions for me.
Oh, good.
That just answers so many questions for me.
Now, if you can't do it on your calculator.
Thank you, whoever asked that.
How do we get back to the standard graph again? Second and
No, it's zoom. The one in the middle, zoom. And see number 6 down here says standard. 6.
yes, ma'am.
I'll get you back to a 10 by 10.
Okay, thank you.
You're welcome. You can use this if you don't know how to graph and don't want to graph. You can use the negative b over 2a. That's that part of that quadratic formula that's in the front. And that will get the x value of your vertex. In our case, it'd be negative 24 over 2 times 4. Somebody needs to mute, please. And that's negative 24 over 8, which is negative 3. Now, see, that's what I got for my x value. Then I put that in my problem. Negative 3 squared plus 24 times negative 3 minus 3. And I'm not going to try to do that in my head. I'm just going to grab my calculator and use a blank screen and put it in just like I have it here. 4 parentheses negative 3 squared plus 24 parentheses negative 3 minus 3 and hit enter, and I get my negative 39. So my vertex is negative 3, negative 39. Doesn't matter which way you do it. You can do it either way, or you can do it both ways, just to double check yourself. Any questions on that? Okay. All right, let's go to the review for our last work. This is a review for 8.4, and I'm going to do a couple of problems that I saw some students had some trouble with.
So, Dr. Solomon, we're only doing 2 for this today?
Yes, we're only going to do 2 today because 8.5 is a little bit long.
Okay, yes, ma'am.
Okay, number 11 is find a polynomial function of lowest degree with rational coefficients. Now, I told you the other day, those are just words that the author has to put in here to make the theorem true. That has the given numbers as sum of its zeros. Remember, zeros are the same as roots, are the same as solutions, are the same as x-intercepts. Those are all the same. And of course, if it's I, it won't be an x-intercept. But they give us 2 of them. They give us the square root of 2, and they give us 5i. So because we learned that there are such things as conjugates, we know that there are 2 more roots or 2 more zeros. Can somebody tell me what the other 2 zeros are?
It's just going to be a negative square root of 2 and then negative 5i.
Because they have to be conjugates of the 2 that we have. If they're square roots or i's, they're going to have conjugates. If they're plain old rational numbers, they won't. But if they're square roots or i's, they will. So now then, now I'm going to go ahead and go through this process again because I had a question about it from one of the students. This means x equals 2, the square root of 2. If I were going to solve this thing, I would have x equals the square root of 2. That's what the 0 says. It also says that x equals 5i, x equals negative the square root of 2, and x equals negative 5i. That's what that would have said when I got it solved. That's how I knew those were zeros. Now, if I subtract those numbers from both sides, I get x minus the square root of 2. And that is a 0. That's saying that it's a 0. And minus 5i and minus 5i gives me x minus 5i. I'm going to add the square root of 2 here, and I get x plus the square root of 2. And adding 5i gives me x plus 5i. And see, those are those factors. X minus the square root of 2, x plus the square root of 2, x minus 5i, x plus 5i. But there's a shortcut. If you just remember to say x minus the 0 that they give you, then you can skip this part right in here where you set the x equal to those, then solve them. You can skip that part if you can just remember that to get the factors, you're doing x minus the 0 to get the factors. Okay? Any questions on that? All right, now then, what we want to do with those factors is to multiply them to get our polynomial. We want a polynomial function. So what we're going to do next is to write these down, and I'm going to be smart when I do it. I'm going to put my square roots together, and I'm going to put my i's together. So my f of x, when I get through with it, is going to be x minus the square root of 2, and x plus the square root of 2, and x minus 5i, and x plus 5i. When I get that all multiplied out, that's going to be my polynomial. And I put them together so I can be smart and hopefully eliminate some things. So I'm going to multiply these two, and then I'm going to multiply these two. So let's look at this. X times x is x squared. X times the square root of 2 is x times the square root of 2. X times negative square root of 2 is negative x times the square root of 2. And then negative square root of 2 times positive square root is negative square root of 4. So those are the first two multiplied together. Let's do the last two. The last two is going to be x squared plus 5xi minus 5xi minus 25i squared. Ding, ding, ding. Did the bells go off in your head when I wrote I squared? We talked about bells yesterday or Tuesday. Let's simplify this. We'll have an x squared. These two will cancel. And 4 is, square root of 4 is 2. So I have minus 2. Okay. Then in the second one, I have x squared. The 2 in the middle cancel. The I squared is negative 1. So I squared, substituting in negative 1, would be negative 25 times negative 1 would be positive 25. Okay, now then all I have to do is multiply these. We get x to the 4th plus 25x to the 2nd. X squared times x squared times 25. Then I have a minus 2x squared when I multiply by the negative 2 and to negative 50. Now 2 of these in the middle will combine, and we'll get 23x squared minus 50. And there is our answer for this problem. Any questions on it?
Can you move it up just a little bit? I was still writing it down.
Okay, there's not
Okay.
anything under it, I don't think.
X4. Oh, I just couldn't see that bottom part.
Okay, can you
Plus
see it now?
23x, yes.
Okay. If you're working one of these and you don't get rid of the radical, then you've probably done something wrong. Okay. All right, let's do one more from 8.4. And this is a long, hard one. So, Just get ready. Now, I want to warn you on this test, guys. There's 25 questions on this test. They are equally weighted. So these problems like number 18 is worth the same thing as one of those that says graph, or one of them that says find the domain, or one of them that says factor. Those are all the equally weighted. So make sure you get the easy ones that you don't have to do a lot of work on it done first, because these that have 4 and 5 parts on them, each part is worth a fraction of the points. So just know that you can spend a lot of time on these long ones when you should be spending your time on the short ones to get them done. Just know they're all equally weighted. This one is number 18, and it says find the rational zeros, and then the other zeros of f of x equals x to the 4th minus 3x cubed minus 20x squared minus 24x minus 8. And whatever problem you have for this number 18, it's going to start with an x to the 4th. So you can bet on having 4 zeros when you get through. All right. They don't give you any of the zeros like sometimes they do. And you can use synthetic then to break it down. So your best bet when you don't have any zeros is to graph. Graph to see if you can find any zeros. Okay? All right, so I'm going to put this in my calculator. X to the 4th, x raised to the 4th. Then I have to do my arrow key to bring that cursor down. Minus 3x to the 3rd minus 20x squared minus 24x minus 8. So I double check kind of to make sure I put it in there correctly. And then I'm going to graph it. Okay, I can see that it looks like a 4th degree. It's kind of looking like this. That's what it looks like. Okay. So I can see that there's going to be 4 places that it crosses. So I'm going to see if I can find some of them. I'm going to do second and table and look for some. I look down here and I see one at -2 and one at -1. Do you guys see that? At -2 and -1, the y values are 0. So there's 2 of them right there. Now I can get that down to quadratic and find the other 2. Let's see if I can look at my graph and kind of see where it is. There's another one that's right here. It looks like it's between maybe 6 and 7. There's another one. And it looks like there's one right in here between 0 and -1. I think there's another one. But those are probably ones that are fractions or have radicals on them or something. But these 2 are real good ones right here that I can start with. So that's what I did, was grab my calculator, graphed it, used my table to find those 2 zeros. And I know they're zeros because the y value is 0. So I have a -2 and a -1. So I'm in good shape. So what I'm going to do is put my -2, I'm going to start with it in synthetic division using the coefficients of my terms that are here. So it's 1x to the 4th minus 3x to the 3rd minus 20x to the 2nd minus 24 minus 8. Now, if I did this right, I should end up with a 0 on the end down here. That would tell me that that negative 2 is in fact a 0 of the function. So bring down the 1. Negative 2 times 1 is negative 2. Negative 3 and negative 2 is negative 5. Then I multiply negative 2 times negative 5 and I get a positive 10. Negative 20 and a positive 10 is a negative 10. Negative 10 times negative 2 is a positive 20. Negative 24 and 20 will be a negative 4. And it did happen. I get an 8 here, which makes that a 0. So I have proven that negative 2 is indeed a 0 of this problem. Now what I want to do is, because I did this negative 2, I can put that negative 1 in this part of it right here. Don't start all over. Just start from the one, it's called the depressed equation. Start right there and put in your negative 1. And it'll break your problem down even further. So start from there. And you get negative 1. That gives me a negative 6. Or positive 6. That gives me a negative 4. And look, it happened again. So I know that is right. So I've proven that negative 2 and negative 1 are zeros. And in addition to that, I have reduced my problem down. Let's see. If this started x to the 4th, then this one is 1 less. So it's x to the 3rd. So this one's 1 less than that, which is x to the 2nd. So what I have now is 1x to the 2nd minus 6x minus 4, and I'm going to set that equal to 0 and see what I can do with it. Any questions on what I've done so far to get the 2 zeros that I've proven are zeros and reduce my equation? Okay. Now then, I can't factor 4 so that when I subtract I get 6. So I know it's probably going to be a radical anyway because I couldn't see it over there. A is 1, B is negative 6, and C is negative 4. So I do x equals, using the quadratic formula, the opposite of that B, plus or minus the square root of B squared minus 4 times 1 times negative 4 all over 2 times 1. So now I have a positive 6 plus or minus 36 plus 16 over 2. And that is 6 plus or minus the square root of 52, if I added that correctly, over 2. 52. Is there anything that I can multiply together to get 52 that might be a perfect square? Anybody have an idea? Need to see if I can break that 52 down into perfect squares. What times what is 52? Anybody know?
2 times 26.
2 times 26, but neither one of those are perfect squares. So I have anything else? 26 will go. 2 times
4 and 13.
4 times 13.
4 times 13. That's it. 6 plus or minus. Whoever thought of that? Good deal. 4 times 13. And see how you can, if you got 2 and 26, you could break your 26 down and see right here you've got a pair of 2's, which would be a perfect square 4. So you can do it that way. Plus or minus the square root of 4 times the square root of 13. And the square root of 4 is 2. Let's see where I'm going to move to here. I have 6 plus or minus 2 square roots of 13 over 2. Factor out a 2. And I get 3 plus or minus the square root of 13, and my 2's cancel. So I have 3 plus the square root of 13 and 3 minus the square root of 13. Those are my other, you could call them other zeros. These are irrational zeros. And my rational zeros are -2 and -1. Now, how would I write all that in factored form? Because that's the other thing it says. You have to write them in factored form. After you get these 4 zeros, how do you write it in factored form? Does anybody remember? It's x minus the 0 is the shortcut. So I'm going to have x minus 3 plus the square root of 13, x minus 3 minus the square root of 13, x minus a -2, and x minus a -1. And I have to clean it up. They won't take it in that form. This one will be x minus 3 minus the square root of 13 because that minus will change those signs. This one will be x minus 3 plus the square root of 13. This one will be x plus 2. And this one will be x plus 1. And there is your factored form of the function. Now, each part of that, like this part is one answer, this part is one answer, and this part is one answer. So each of that is a third of the points. So keep that in mind as you're doing it.
Yeah, I'm probably not gonna do that problem
Why not?
because
It's
juice
too
isn't worth the
much.
squeeze.
That is a
That's-
lot.
That's too much. Like,
I pure and simple. Too much
it's
work.
not even
Too much work.
It's not even the fact that I don't know how to do it. It's just, oh my God.
You know
Too
what it
much.
is? I can tell you
It's,
exactly.
it's like, what?
It's because you haven't done it enough times. I'm trying to fix this. I got a note from somebody that said they couldn't see it. Is anybody else having trouble seeing the writing?
I got a question when you
Mhm.
said the rational zeros were -2 and -1.
Uh-huh.
Did we already do that up there, right?
That's when we found it using the graph. That's when we
Right.
found those.
And when you said the other zeros, like which one are the other zeros?
The other zeros are ones that are not rational. So it's these two. 3 plus the
Okay.
square root of 13 and 3 minus the square root of 13.
Okay.
Now, those problems are long, so you haven't done but maybe 3 of them. So if you want to get the points from this problem on the test, you're going to need to click that little thing that says, give me a similar problem and do some more. You have to work these a few times for you to be able to go, oh yeah, these aren't so bad. I can do these.
The synthetic division part is easy, but so I guess it's like we're doing the synthetic division, then we're having to do the quadratic equation.
If this had been able to factor, you wouldn't have had to do this part. But you can't factor
Right.
4 so that when you subtract it, you get 6. So you have to use the quadratic formula to do that one. And you
Okay.
could get, it's pretty easy to put it on your calculator and get these two. That at least gives you a third of the points right there. You can write
Right.
those two down.
I think my problem is I don't know where to stop.
Okay, well, you stop. That's a good question, actually. You stop when you end up with 4 zeros. See that 4? That tells you there are 4 of them somewhere.
Okay, that does help.
Whatever your leading exponent is, your degree of your polynomial, That is how many zeros you're going to have. Okay.
Yes, ma'am, thank you.
Any other questions? Okay, well, let's look at our poll problem for tonight and see if you can do this poll for tonight. And I don't want anybody to say my answer's not up there, okay? All right. I'm going to do some checking of some attendance here. See who I've missed. Okay, Selena, is Selena there? Or Brooke called and said she wasn't going to be here. Tamala, is Tamala here? Kiera Thomas? Danielle Westbrook. Is Danielle here? Okay, let's see what we've got here for a question. We have a couple of people that haven't answered. Maybe they can't. Might be on their phones. Which type of problem do you consider to be the easiest? No one put solving equations? I can't believe it. Okay, multiplying polynomials is easy, and so is graphing. Finding domain. All of those seem were pretty even there, actually. So solving equations wasn't easy for anyone, huh?
Actually, it is. It's just, it said the easiest. So graphing was the easiest, but solving equations would have been my second easiest thing.
Would that be your second one? Okay.
Mhm.
Solving
Right.
equations comes with too many exceptions for the answer.
You're right. There's a lot of ways to do it. Sometimes you graph, sometimes you use the quadratic formula, sometimes you use the square root, and sometimes you have to set them equal to 0. And yeah, there's all kinds of, sometimes you have to factor.
Or some of them just stop you midway. So like factor this as best as you can, not find the zeros or anything like that. Like I don't know who said it, but knowing when to stop is
Exactly,
on.
that's what I'm saying. I don't know where to start either.
But you can do the middle. Can you do the middle, Amanda? You just don't know where to stop.
Yes, I know, I need to, that's what I struggle with is okay, do I start with synthetic division and then go to this or this and then where to stop? Like Eric said, I don't know what simplest form I need it to be in or if it's already there.
Well, that's a practice thing. And I'll tell you, if they give you any zeros to start with, any, then you use that one in your synthetic division and break it down. Once you get to the quadratic form, once it's x squared, you can use the quadratic formula or you can factor or whatever you can do to get it to work from there. But if they don't give you anything at all, then you're just grabbing in the dark unless you want to use those P over Qs and go through all of those rational possible roots that we did the other day where you had to find the P and find the Q and get the factors of each, put P over Q. You could do that and go through all that list if you want to, or you can grab your calculator and see if you can find any zeros. You can almost always find at least one zero by graphing and look down your Y section. And if it says 0, then that x value is a 0 of the function. So you put that x value in your little box for your synthetic division, and then see if it's a 0 on the end. If your remainder is 0, that proves it's a 0. So if you don't have anything, do the graphing. If they give you 1, put it in and see if you can break it down. Okay?
Yes, that helps.
All right. I guess I didn't share the results there with you. There you go. You can see what everybody said. Okay. All right, let's talk about what we're going to do tonight. Tonight we are going to do asymptotes, and those that's a funny word, asymptote. For the longest time I had the hardest problem with students abbreviating asymptotes as ASS. It took me forever to get students to quit doing that, and I haven't had any problems in a long time. So I don't know what happened, but they quit doing that. Maybe they grew up. I don't know. But let's talk about 8.5. This is what we're going to do. The first part of it is easy, easy, easy. It is factoring. That is the section that's for the support. It is factoring, and it's not hard at all. I think you'll remember doing it from when we did this before. They give us a lot of practice in this course on factoring. Okay, when you factor something like this, and this is number 7 actually off of your homework, you can see that they all have an A in common. The 13 messes up any other number, but you can take out an A out front, and you'll get 12A squared minus 13A minus 35. Now, this is not necessarily a pleasant one, but this is an AC trinomial because you have a number in the front and a number at the end. So that's an AC trinomial. You're going to end up multiplying 12 times 35. And I'm going to cheat here because I've done this one already. It's 420. So now this last sign, remember, says that I must subtract factors of 420 to get negative 13 in the middle here. That's what I want. Well, I played with it a little bit, and you can do as much playing with it as you want to, but I figured out that if you use 28 times 15, you get 420. And if you subtract those, you get 13. And you can get a negative 13 if you make your 28 negative and your 15 positive. You can get a negative 13 there. So now then, this is AC, so I bring down the first term, I bring down the last term, and I rename the middle term. Negative 28A plus 15A. Is this getting easier for you guys now that we've done it probably 10 or 15 times? Is it easier?
Yes, ma'am.
Yep.
All right, now I don't want to lose my A, so I'm going to put these little brackets out here. Otherwise, I'll forget that A, and then when I put it in there, it'll be telling me it's wrong because I forgot the A. Group this 2 and 2 and factor out a common factor. Looks like this one has a 4A in common. 12 and 28, they both have 4. So I have 3A minus 7, if I did that correctly. Looks like this one has a 5, and I want a 3, so that's 3A minus 7. Okay, now it looks like I can put my common group there, and then the fronts off of those. And there you go. I have factored it. Any questions on that? The first part of it is all factoring, and that's probably the hardest factoring problem on the support section. So I think that you can probably do that. The last half of it is all simplify. It says the word simplify for the direction. And there are going to be things, and this is one of the harder ones. Most of them aren't as hard as this one. They're going to look like this. x minus 6 over x over 6 minus x. And they look almost the same, except in this one, the x is positive, and down here, the x is negative. And here, the 6 is negative, and down here, the 6 is positive. So if I could get one of them switched around, then something would cancel. So this one has the x in the behind part of it. So I'm going to mess with this one. I'm going to take out a -1 and see what happens. Out of that bottom one, not the top one, just the bottom one. So if I take out a -1, it's going to change my 6 to a negative. It's going to change this negative to a plus x. Now then, I'm going to rearrange it and change that -6 plus x to x minus 6. I have to know that there's understood 1 in front of it. There always is in front of that top one. These two would cancel out, and I have 1 divided by a -1, which is -1. So that's a little trick you can use to turn negatives around and sometimes cancel out binomials. Any questions on that? Are we good? All right, let's go to the harder ones. All of these in the support section are like that. They're not really hard ones to do. I think you'll zip through those. However, in the college algebra, these have multiple parts. These are like those that I did from that other example where you have one problem and there's many things to do with it. They give you a rational function. This one is x minus 2 over x plus 3. And they want you to do a bunch of things with it. Number 1 is to find the domain. And they want you to write the domain in interval notation. So watch out, because one of them I know says set notation. So watch out for your directions to see if it says interval or set. So to do this problem, to find the domain, we've done this before, set the denominator not equal to 0, because that's what it happens. If the denominator is 0, then it's undefined. So you set the denominator not equal to 0 to find out what number it cannot be. So x cannot be equal to -3. If x is -3, and I put -3 back in there where x is, -3 plus 3 is 0, and the 0 in the denominator is undefined. So that's my undefined spot. So if I want to do this in interval notation, I'm going from -infinity to -3, union -3 to +infinity. And that's my domain. Okay, we're good on domain. The second thing they want to do is to find the x and y intercepts. Now we've done this as well. We have done this before. So my advice to you is change your f of x to y, because you know you can do that. So rewrite it as y equals x minus 2 over x plus 3, because f of x means the same thing as y. But I would do that for this part of it. To get the x-intercept, let y equal to 0. That's the rule that you do. To get the x-intercept, let y equal to 0. So I'm going to put a 0 in where that y is. I have this problem. Well, I want to solve it, so I can either cross multiply or I can multiply both sides by the denominator. The denominator is actually a little group, x plus 3. And x plus 3 times 0 is still 0. And x plus 3's over here will cancel because one's in the top and one's in the bottom. Now add your 2 to both sides, and you have x equals 2. So your x-intercept is the point 2, 0. That's going to be important in a minute. All right, now then, someone tell me how you think you're going to get the y-intercept.
Set x equal to 0.
That's right. Very good. Set x equals 0. So we're going to start with this one right here where we changed it to y. I'm going to rewrite it so you won't get confused. I'm going to bring it down here. And I'm going to put in x equals 0. So y is 0 minus 2 over 0 plus 3. So y looks like negative 2/3. So my y-intercept is 0, negative 2/3. Any question about that?
I'm still writing it down.
Okay. I hope all of you have a piece of paper or something, or you can use this video and go back and look, because you're going to need these rules. I posted these rules for asymptotes out there in the content. They're out there, but they're also written in the notes as well. But we're going to write them tonight because I think sometimes when you write down the rules, it'll help you remember them better. So we're about to write the rules for asymptotes. All right. Anyone not finished with this one? Okay. Let's see. Does anyone know what an asymptote is? It's A-S-Y-M-P-T-O-T-E. Anybody know what that is? Any of you super duper people remember this from high school? No?
I know I didn't know how to spell it.
It's a tote, T-O-T-E on the end. Amanda, do you remember it?
I was saying that was 18 years ago for me for high school.
Okay, well, let's talk about that young boy.
23 for me.
Where's Luke? Is Luke still on here? I don't know if Luke's on here still. Donovan or Eric, any of you guys, or Corey, anybody remember what an asymptote is?
I remember something about a line on a graph.
It is a line. Very good. Okay, so an asymptote is a line, and we always dash it. Okay, it's a dashed line. A line, a curve, nears, but seldom intersects. It's really to aid in graphing. The vertical asymptotes, the graph will never cross a vertical asymptote because that's an undefined spot. But sometimes when you have a horizontal asymptote, they will cross it. It is represented by a dashed line. If I can spell dashed correctly. Line. It can be vertical, horizontal, or oblique. Oblique is an old people word. It's been around forever. That means it's slanted. Okay, so an asymptote is a line that a curve nears. And ours are going to be polynomial curves. They're going to be actually rational curves that split off, because you're going to have probably a vertical asymptote that is going to break up your graph. It's because it's a place that's undefined. So let's see what the rules are. Okay, the first one is vertical. It looks like that. To get this one, you set the denominator equal to 0 and solve. We've done that before. It was the undefined places. We've already said what makes this rational function undefined. Okay. It is a line, so you need the x equals part. Need the x equals, and then it's the undefined value. Okay. So there's a connection between the domain and the vertical asymptotes. The domain that we did a while ago, the domain over here, we set this not equal to 0, and we found out that x cannot equal to -3. This is the same thing, except we set it equal to 0 because you want to know what the line is that goes through here. So that's what you want to do. You're going to set it equal to 0 instead of not equal to 0 for vertical asymptotes. Let's do horizontal ones. Those are the fun ones. Those are the ones that go this way. Okay? And you have a little rule. I'm going to explain this in just a minute. You're going to have a function. It's going to be a rational function. You're going to have some coefficient here, some x here, some exponent m here. And then it's going to be plus a series of other things in the top. In the bottom, you're going to have some coefficient. I'm going to call it b. You're going to have a variable x. And you're going to have some exponent n down here, plus many other things. Okay? So there's 3 rules to this. If m is less than n, so if this exponent in the top is smaller than this exponent in the bottom, then y equals to 0 is the horizontal asymptote. Okay? So m could be less than n. M could be equal to n. They could both be 3s. Like this would be cubed and this would be cubed. Or this would be to the 4th power and this would be to the 4th power. So they could be equal. And in that case, you do y equals a over b for the horizontal asymptote. That would be like if this was 3x to the 4th and this was 2x to the fourth. Those fours, that m and n would be equal, so that would be 3/2. You use the coefficients. If m is greater than the n, there is no horizontal asymptote. But there may be an oblique asymptote if m is 1 degree more than n. Okay, so let's go over those rules again. Horizontal, you're going to have some number times some x times to some power over some number times the x to some power down here. And you're comparing these little exponents. If m is less than n, y equals 0 is the horizontal asymptote. If m is equal to n, then you have to use these coefficients. Put a over b. If m is greater than n, there is no horizontal one, but if it's greater than m by 1 degree, then that's how you have an oblique asymptote. They used to call these a long time ago in one of the books slant asymptotes. Okay, this one you use long division to find the asymptote. Throw away any remainder. So y equals the quotient is the oblique asymptote. Okay, so we have 3 kinds of asymptotes. Vertical, that's where you set the denominator equal to 0 and solve. There's the horizontal. That's where you have to compare the exponents. The top one's smaller than the bottom one, it's y equals 0. If the top one's equal to the bottom one, you have to do y equals the coefficients over each other. And if the top one's bigger than the bottom one, there's not one. But there might be an oblique one if the difference between them is 1. And so then you'll have to use long division. There is one problem in your homework that should have to use division to find it. We'll try to get to it tonight. We might. It could happen. All right. So I'm going to wait a second till people are caught up. Let's see. Chandra, can you tell me when you're finished? Maybe that will be a good clue to when we can go on.
Yeah, I was already finished.
Are you finished?
Mm-hmm.
Anybody else need more time? I don't want to hurry. These are out there for you. Let me show you what I think I've got it here. Looks like this. It's actually typed. That came from many years ago, actually. I used the same sheet a long time. Okay, let's go back to our problem we've had, because we've got to find the asymptotes. This is part 3 to the problem we had. Find the asymptotes. So we have vertical ones. Our problem was f of x equals x minus 2 over x plus 3. And we want the vertical one, so all we do is set x plus 3 equal to 0, subtract 3, and we've got it. X equals -3 is your vertical asymptote. Okay, let's do the horizontal. Let's see, let me put some numbers in here. 1x to the first minus 2 over 1x to the first plus 3. So this one up here is the m, and this one down here is the n. So would I say m is less than n, m is equal to n, or m is greater than n?
Equal.
So m is equal to 1 and n is equal to 1, so m is equal to n. So we're using the one that says if m is equal to n, y equals a over b. So a is 1, b is 1. So y equals 1 over 1, or y equals 1 is my horizontal asymptote. There is no oblique. If you have a horizontal, you won't have an oblique. Okay, then the next thing you want to do is graph. Okay, when you graph, you want to put in the asymptotes and x and y intercepts. Okay, that's what you want to do. So we have a vertical asymptote at -3. So I'm going to come over here to -3 and draw a dashed line down at -3. I have a horizontal one at y equals 1. So I'm going to draw a horizontal one across this way. And then, let me see, my other sheet had my x and y intercepts, 2, 0, and 0, -2/3. 2, 0, and 0, -2/3. So that kind of gives me a space to work in for my picture. Now, it's probably going to be advantageous for you to actually put a graph in here until you get used to doing these. If you have a top part of it, you want to put it in parentheses, x minus 2 in the top, divided by parentheses x plus 3 in the bottom, and just get a picture of it so you can kind of see how the shape of the curve looks. See that? I can even double
ahead.
check my table and see that at 2, I do have a 0 here. I do. Now, question, did you have a question?
Yes, so when you were graphing it, okay, you did
This is the x equals -3 for one of them. This is the y equals 1. That's the horizontal one. And then I put in this point, which is the x-intercept, and this point, which is the y-intercept. And now I'm just going to generally follow those asymptotes because the curve's going to get close to them, but it's not going to cross it. So that's the way those look. Now, this graph will be choice. It'll be a choice. So you'll have 4 choices down there, and you'll have to pick the right one. They are not going to make you graph these by hand. They're too difficult to graph, and there's 2 branch curves, so they're not going to ask you to do that. They will have a choice for you to pick. So put it on your calculator, and you can see which picture it is.
Can you put it in the calculator one more time just so I can make sure that I'm doing it right?
The y equals? Is that what you want?
Yes, ma'am.
Okay, the x
Uh-huh.
minus 2 is on the top and it goes into parentheses. And then I hit the divided by bar to get
Okay.
that slash. And then the x plus 3 was in the bottom.
Okay.
Okay.
Divided by x plus 3.
Anything that's in the top, the numerator, you've got to have parentheses around, and anything that's in the bottom. Otherwise, what the calculator will do is divide 2 by x, and it'll look crazy, and you'll go, what in the world is that? I've never seen a graph like that.
Now the points you said, now where the
These
points that was
2
on
points,
the graph?
these 2 points, they ask you to graph them. It's nice for you to know that those points are points to graph because you have to put them in here. 2, 0 is the x-intercept, so I went 2 over and 0 up to put that first one there. And then the y-intercept was negative 2/3, so that's 0, negative 2/3. That's that one right there. 0, negative 2/3 is that one. And this one's 2, 0. Now, honestly, just to be truthful with you, you don't have to do that unless you're going to be in a class where they are going to ask you to graph it by hand, because you can graph it on your calculator and you don't have to put those asymptotes or the points in there. That's beneficial if you're going to graph it by hand in a class. If you were in my class and we were doing this test, this portion of the test would be graphing by hand, not picking a multiple choice answer. So that's why that's important for you to be able to do. They still kept it in there. Although if I were you, to make it easy, I would just graph it and see what the picture looks like and pick the right one.
Now you said the x and the y intercept, like I'm trying to figure out, did I just miss something? Like
I don't know. We did it right here. X and Y intercepts. You change your f of x to y.
oh, okay, that was on another piece of paper. That's why I got confused. I'm like, what? Where was that at?
Yeah. It's
Okay.
that same problem. See, it's
She did it at the top of the page too. At that second page. Yep. You see it?
I hear baby shark. Are y'all feel like you're getting eaten by the sharks? Okay, any more questions about this before we go to one more difficult? There's a step up from this. Okay, this next one is for those of you that want to aspire to be math teachers or engineers or business majors. This will come back up in business. If you want to be an astronaut or work at NASA, you're going to see a bunch of this. So these are for this is the next level up, and it's one of your problems that you're going to have. We're going to start with this. Sometimes there is a hole, a secret hole in your graph. It's like one of those holes in space. And that actually, when you do holes in space, you have to do this kind of thing. It's a lot more complicated than this, but the concept's the same. If there is a common factor in the numerator and denominator, those factors cancel, but where they are 0 will make a hole. So we're going to do one and show you what that means. you're going to see these little holes in your pictures on those things, and you're going to go, what is that? Why is there a hole in that graph? That's because somewhere there's undefined. Let's do this example. This is number 16 off of your homework. You're going to have a problem just like this. So dig this out when you do this number 16. Put it by you so you can get it done. We have x squared plus 4x minus 5 over x squared plus 9x plus 20. All right, what you want to do is factor the top and the bottom if you can. And we can. So the top factors into, let's see. Got to subtract factors of 5 to get 4. So that's going to be x plus 5, x minus 1. That gives us 4x and negative 5. So that's good. In the bottom, we've got to add factors of 20 to get 9. That's x plus 5 and x plus 4. So we factored the top and the bottom. See that, guys? That's what you want to do first, if you can. Then, don't cancel those out yet. We're going to do that in just a minute. To do the domain, which is the first step that you've got to do, you set the factors, both of them, equal to 0 from the denominator. So I have x plus 5 equals to 0, and x plus 4 equals to 0. Subtracting 5 gives me x equals negative 5. Subtracting 4, I have a toy talking to me over there, equals negative 4. So this is for my domain. You don't cancel those out till after you get your domain worked. I've got to skip negative 5 and I've got to skip negative 4, and they want it in interval notation. So I'm going to go from negative infinity and up to negative 5. Then I'm going from negative 5 to negative 4. And then I'm going to go from negative 4 to positive infinity. That's domain, and we've done that before. That's going to skip the negative 5 and skip the negative 4. Everybody okay with that? We good?
Yes, ma'am.
Okay. Now let's deal with this whole. Okay. I'm going to rewrite this and show you what happens here. These two are going to cancel. They're the same, so they're going to cancel out. But where that cancels is where there's a hole. So you're going to pick one of those and set it equal to 0 to find out where that hole is. It's when x is equal to negative 5. Then use the reduced function to find the y value of the hole. It's not an asymptote, a vertical asymptote. It's a hole there. It's still an undefined place, but it's not a line. It's a little circle. So we're going to use the reduced part, x minus 1 over x plus 4. So I'm going to have y equals negative 5 minus 1 over negative 5 plus 4 when I put negative 5 into the x right there and there. That gives me negative 6 over negative 1, which is equal to 6. So my whole is going to be found at negative 5, 6. Okay? Questions? It's because the common binomial from top to bottom canceled. You were not finished with that. Okay, let's do the vertical. This is part 3, vertical asymptotes. We had, remember, f of x equals x minus 1 over x plus 4 for the reduced part. So, oh, I'm sorry. My table is off tonight. I'm not sure what my problem here is. X minus 1 over x plus 4, this is the reduced form. So I set this equal to 0, the bottom, and I get x equals negative 4. There's my vertical asymptote. Okay.
So the vertical is whatever we're just taking the one in the denominator and doing it. Okay.
Okay, so then let's try the horizontal. For the horizontal asymptote, just because, use the original problem. I think you could always use reduce, but the rule is to use the original, but so I don't want to say that you can always use the reduced. All right, so our m is equal to 2, and our n is equal to 2. So that means m is equal to n. So I grab my rule sheet, and if m is equal to n, y equals a over b. So I do y equals, there's a 1 in front of these, 1 over 1, or y equals 1 is the horizontal asymptote. And if there's a horizontal, there is no oblique. Okay. Now the next thing we want to do is find the x-intercept. There'll be a spot for you to give the x-intercept. Remember, this is when we let y equal to 0, and we can use the reduced form for this. So let's use y equals x minus 1 over x plus 4. I'm going to put the 0 in for y, and I get x minus 1 over x plus 4. And multiply by x plus 4 on both sides. 0 equals x minus 1. So x equals 1 is the x intercept, that point would be 1, 0. Okay, now let's do the y-intercept. That's where we let x equal 0, and we can use the reduced form. So y equals 0 minus 1 over 0 plus 4. Y equals negative 1/4, so that's the point 0, negative 1/4. Okay, the last thing we want to do is graph it, and I'm going to graph it by hand, and then we'll do it on the calculator. The graph. When you're doing a graph and you're doing it by hand, you want to put in your asymptotes. There's one at x equals negative 4. We found that out from your notes. You can look at that. And we've got y equals 1. That's there. And the x-intercept is 1, 0. And 0, negative 1/4. Looks like that last one we had. And this one also has a hole in it, remember? This one has a hole at, where was our hole? Negative 5, 6. There's a hole. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Up here somewhere there is a hole in this graph. So you draw a little circle on it, and when you look on your paper, you'll see that hole. It'll be pictured there. So this one's going to go down this way, and this one's going to come through here like this. So let's look at the picture of it on our calculator and see if we can come up with it. It starts, and I'm using parentheses around the top, x squared plus 4x minus 5 divided by x squared plus 9x plus 20. All right, let's see if we can get a picture of it. That's what it looks like. And let's check out that hole and see what it says. There's the picture of my graph right there, but there's a hole somewhere. Let's see if we can find it. Let's go over here where x is equal to negative 5. And see where it says negative 5, there's an error. That's because that's an undefined place. It has a little circle there, a hole. It's also got one at negative 4, but that's an asymptote. It has an error there as well. And we can check to see that our 0 is in, our x-interception's in there. Where was our x-intercept? 1? Yep. At 1, the y value is 0. At 0, we can see that one too. It's negative 0.25. It's negative 1/4. We can see that one as well. Okay, so what you're doing is looking for the picture, and if you see one that doesn't have the hole in it as opposed to one that does, you want the one with the hole in it. Because this one happens to have a hole, the two factors cancel out.
On the other page, I didn't get to finish the bottom part.
Let's see which one.
Just the last page that you did before that. I was trying to do the x-intercept part
X-intercept.
at the bottom.
Is it this one?
Yeah, I think so.
Okay.
So the y was 1. Okay, I knew that. And then get that. Let me see. Okay, equals. Wait a minute. Okay, I got a question.
What is your question?
So did we plug in, maybe this is taking me too fast, but so the y equals x over 1 and the x over 4, is that just a reduced form or?
This one right here? Yes.
No, the bottom, like we already did the x-intercept. So,
So the y-intercept,
right,
you're using the same reduced form, x minus 1 over x plus 4. This is the one that already has the x plus 5s canceled out. Remember, these two canceled out. So
right.
this is what's left. It's the reduced form of it.
Okay, yeah, I didn't.
Then you put the 0 in for x to get the y-intercept. You put 0 in for x. It gives you negative 1/4.
Okay, so up there though, when you multiply, did you multiply the x plus 4 over on the other side of
I
there?
did.
Okay,
This times this is 0. That's what this makes. And these two will
right,
cancel, so you just have the x minus 1 on that side.
right. Okay, x minus 1. And so that will be x equals 1.
Uh-huh. That's right.
Then the y equals x over 1, x plus 4. Y equals, sometimes, I mean, before I'm trying to get what it is before I'm writing it down. I don't want to just copy it and not know what I'm doing.
Well, some people are people that have to copy it and do it as they go. And some people can look at a
That's me.
page. They can look at this whole page, and they're called holistic learners. And what they want to do is look at the whole thing, and then they can pick up the parts. But some people can't do that. They have to do each little part, and then they have to do it several times, and then they get it.
Okay, I'm finished with it now.
Are you finished?
Yes.
Okay. All right. So let's start this assignment. We have a few more minutes, and we're going to start this assignment and see what it looks like at the beginning. Some of the beginning problems are those, of course, I did the hard ones for you because I knew you were going to run into those and you'd get stuck and wouldn't know what to do with them. So we're going to look at some of these problems and see what they look like.
I have a quick question.
Yes.
If we have a horizontal asymptote, we don't have an oblique one, but when would we ever not have a horizontal one?
If M is bigger than N,
Refer to the rule page.
if M is bigger than N, you will not have a horizontal one. You'll have an oblique one probably. All right, so let's look at this number 1. This is section 8.5, and this is the way it starts. So don't let all those hard ones scare you, because you can certainly start this. Determine the domain. And they give you f of x equals x squared over 10 minus x. Okay, that's the problem. And it doesn't tell you to do domain and x and y intercept and the vertical and asymptotes. It doesn't do all that. It just says find the domain. Starts you out with the easy ones first. So to do that, you set 10 minus x equal to 0. Not equal to 0, I guess, because we're doing domain. Now then subtract your 10. And you get negative x is not equal to negative 10. Divide out your negative 1, and x cannot be equal to 10. If it is, if x is 10, you can see 10 minus 10 is going to give you 0 in the bottom. But they want you to write the domain in interval notation. So you would do negative infinity up to 10. Union 10 to positive infinity. Remember doing that before? We've done that already, so hopefully that won't be hard. Okay, number Any questions on 1? Number 2, this is find the domain. And this time they give you,
Dr. Sullivan, I can't see the top of the paper.
there we go. Is that better?
Yes, ma'am. Thank you.
Okay. Find the domain f of x equals -3 over x squared plus 2x minus 35. All right, so what do you think that we have to do on this one before we can have something that we can set not equal to 0? What do we have to do first?
We have to factor it.
That's
Factor
right.
out.
That's right. We got to factor it. So let's see if we can factor this. It's a simple trinomial. We have to subtract factors of 35 to get 2. Does anyone have an idea what those two numbers might be?
7 and 5.
7 and 5. 7 was going to be positive because your middle number is positive. 5 is going to be negative. Now, you do that rule up there, set each one not equal to 0. And x cannot be equal to -7. And x cannot be equal to 5. So how would we do that in interval notation?
Be negative infinity to -7.
Good.
The union. And then it'll be -7 to +5.
Good.
The union, and then it'll be +5 to +infinity.
Good job. Very good. Very good. Okay. Those two are not too bad, and that's the way you're going to start. Everybody okay with that? Anyone okay? Not okay? Are we good? All right. Can I change it yet?
Yes, ma'am.
Okay. Number 3 says list all asymptotes.
Is this college algebra or support?
This is college.
Okay.
All of the support ones are factoring. Here, you want to see it? Factor.
No,
Factor.
no, I don't know.
Factor.
I just wanted to know which one we were doing.
Yeah, this one's not the support for this 8.5 is all factoring. See it? Till you get to number 8, and then it's simplify. You have to simplify. But it's not, that's not hard. That's not a hard section. So this problem is r of x equals 7 over x squared minus 100. So we have to find all of the asymptotes. So let's start with vertical. We've got x squared minus 100, and that we want to set that equal to 0 and figure out what that's going to be. We can factor that into x plus 10, x minus 10. The x squared minus 100 is a difference of two perfect squares. So then we just set each one of these equal to 0. Remember, on vertical asymptotes, it's set them equal to 0, not that is not equal to 0. So we have vertical asymptotes at 10 and -10. Okay, now let's do horizontal. going to rewrite the problem and put in an x to the 0 so you can see where I'm getting the information that I need. I guess it's an R. I can write that 7 as 7x to the 0 if I want to. And I'm doing that because I have to know the exponent that goes up there. So
Is
this
there an X up there at the very top? Because it just says 7.
7x to the 0.
No, that's what I'm saying. Like at the very top where it says list all the isotopes.
Yeah, this is a 7.
Okay.
But I can add an x to the 0. Does anybody remember what anything to the 0 power is?
0.
Nope. That's what people think usually, but that's not right. Anything to the 0 power is 1. So 1 times 7 is still 7. So I can put an x to the 0 in there just so I can find my m. My n is right here. So m is equal to 0. N is equal to 2. So m is less than n. Now look at your little asymptote sheet and see what it says when m is less than n. What does it say?
Y equals 0.
Y equals 0 is your horizontal asymptote. Okay? And there's no oblique because you have a horizontal one. Then it says to graph it. Notice we don't have any holes in this one. There was nothing that factored out. So the graph is going to have a vertical one at -10 and +10, and a horizontal one at 0. This is an interesting graph. Let's see what it looks like. This one has 7. I'm going to put my 7 in parentheses just because I like to always follow that rule about putting the top in the parentheses. Then I'm going to say divided by, that'll put my slash in between there, x squared minus 100. Let's see what this little funny thing looks like. Well, I can't hardly see it. So let me see if I can get it to branch out a little bit. I can't hardly see all of it, can you? Let me see if we can get a better picture if we change our window to maybe -50 and +50 and count by 5s instead of those. Let's see if we can get a picture of it this way. Well, sort of. Still not easy to see, is it? Let's do our window for our x. Whoops. Yep. 10, 10. I don't know if that will help or not. Let's do a -5 and 5 and see if that helps. Sort of. You can just about see it now. Let me show you what it looks like. It has a little parabola looking thing in here, which is where that x squared minus 100 comes from. And this one goes this way, and this one goes this way. And that's what that thing is doing. It's hard to see it. Let me see if we zoom in or out, it would help. I don't think it's going to. It's just going to show it. Yeah, maybe you can see it a little better there. There we go. That's a little better picture of it. I zoomed in to try to get a picture of it, and you can see it at that point a little better. But it looks like that. And you
Did you
again,
put, did
I'm
you
sorry,
put the graph to parentheses?
I
Because
did.
I was trying to make sure I didn't
I
put it
did. I put a
in.
parentheses around the 7 and a parentheses around the x squared minus 100.
Okay.
Okay. All right. So that's number 3. That's all you had to do. You didn't have to do all the other things it's asking for. Let's try number 4. See what it looks like. List asymptotes and graph. And they have f of x equals 5x cubed over x squared minus 9. So let's do the vertical. And we'll have x squared minus 9. That's x plus 3 and x minus 3 when I break that up. So I have x plus 3 equals to 0. Gives me a vertical asymptote at -3. And also there's one at +3. Okay. Then let's do horizontal. The m is 3. The n is 2. So m is greater than n. Amanda, what do you think happens on that one?
Oh, hold on, let me flip my pages here. If that is, there's no horizontal.
There's no
That's
horizontal.
why you asked me. So yeah, so we have an oblique one now.
So we have an oblique one. So let's go to oblique. And this is the way you do it, guys. You do x squared minus 9 divided into 5x cubed, and there's nothing else. You can put the zeros in there if you want to. But all you're really interested in is this into this. So how many times would x squared go into 5x cubed?
Once.
1x. Okay? X times x squared is x cubed. What do I do about that 5? How do I get a 5 there? I need to be able to get the 5 by multiplying whatever this is up here times x squared to get the number here. If I put a 5 in front of it, will it do it? What is 5x times x squared?
5x
5 cubed.
So that's what I want. I want to get the same thing. So now when I subtract, I'm good. But you don't have to worry about the rest of this. You only want this first one. So your oblique is y equals 5x. That's it. Okay, now then we want to graph it. This oblique one's kind of a hard one to do. The slope is 5. So if I start at 0, my next point would be 5 up and 1 over. So this slanted asymptote comes down through here like that. That's y equals 5x is what that is. And we have one at 3. One up here at 3. And one at -3. So this is kind of a strange little thing. You have a little curve down here. You're going to have a little curve up in this part. And in this one, it's a little S curve that comes through here. So let's see if we can get anywhere close to getting the picture of that. In the top, we have 5x raised to the third power divided by parentheses x squared minus 9. Okay, everybody see that? 5x cubed divided by x squared minus 9. Let's see if we can get a picture of it at all. Oh, I've got mine in. Well, there's the middle part of it for sure. Let me zoom out to standard and see if I can get a picture of it. There's that part. No, I can't see the other part. They're too far up there. Let me change my window to up and down. See if I can get it at all. Yeah, there's that little, see those little curves there? You can just barely see them there. They're up in these corners of these asymptotes. And then you have that one down in the middle there. Okay. Any questions? All right, I will keep working until 8:15 if you want, or you can go forth and do your own thing. Have a good weekend this weekend if you're leaving me, and know that this weekend these are due. So hopefully if you have problems, you'll call me. Okay. We'll continue working as long as I have people here. Those of you that want to leave me, and it's time, so you can leave if you want. I appreciate those of you that let me know when you're not going to be here. I appreciate that because that helps me. Okay, let's do number 5. We'll work a few more minutes at these. Number 5 is f of x equals 1 over x minus 5 quantity squared, and we want the vertical asymptotes. So we're just taking the x minus 5 and setting it equal to 0. And you have x equals 5. And this actually means there's 2 of them, but one's right on top of the other. So that's, you don't have to consider the double part of it. That would be a multiplicity in that part. And that's all you had to do on that one. Number 6, you have to find the vertical asymptotes. And you have f of x equals x minus 4 over x squared plus 5x. Again, you're using the bottom. So you have an x squared plus 5x equals 0. Take out an x. Set each one equal to 0. So you have 2. One is x equals 0 and one is x equals negative 5. Okay, number 7 is the vertical asymptotes. I guess they want you to have lots of practice in these. F of x equals x plus 1 over 4 minus x. And you just set 4 minus x equal to 0. And you get negative x is negative 4. So x equals positive 4 when you divide out the negative 1. Okay. Number 8. Number 8 is vertical asymptote. F of x equals -1, and they already have this in factored form. You didn't have to factor it. So you set each one of those factors equal to 0. Get x equals -2 and x equals 5. Okay, any questions on those problems on that page?
No, ma'am.
Okay, anyone not finished that we need to wait on? Okay, let's look at number 9. Number 9 says f of x equals x squared plus 2x minus 8 over x squared minus 5x minus 14. And let's see, 4 and 2, x plus 4, x minus 2, will that factor? Yep. And then the bottom, x minus 7, x plus 2. So you don't have any holes in this one because those factors are all different. So we're setting the bottom equal to 0. This is for vertical asymptotes, by the way. So x is 7 and x is -2. So you have 2 vertical asymptotes on that number 9. Number 10. Number 10 says g of x equals x cubed over 3x cubed minus x squared minus 30x. Okay. Looks like there is going to be one we can factor out on this one, because this denominator you can take out of x, and you'll have a 3x squared minus x minus 30. And when you take out that x, it can cancel into one of these x's up here. So you would end up with x squared in the top and 3x squared minus x minus 30 in the bottom. Because one of these x's would cancel into one of those and make x squared up there. So there is a hole at x equals to 0, because that x, if you set this x equal to 0, that's where it would be. Okay, it doesn't ask about the hole. It didn't ask us to graph it. It just asks for the vertical asymptotes. So we don't have to find the y value of it. But to do it, you would put the 0 back in here, and it would give you the y value of it, of the hole, which looks like it's going to be 0. So now then, let's take our 3x squared minus x minus 30 and see if we can factor that. That's an AC trinomial, which is 3 times 30, which is 90. I need to subtract factors of 90 to get 1. Let's
10 and 9.
Oh, that's good. 10 and 9 will work.
-10 and 9.
Very good. So we have 3x squared that we bring down. We rename that -x to -10x and positive 9x and bring down the 30. Okay. Then we group them. We take out an x and we'll have a 3x minus 10. Take out a 3 and we'll have a 3x minus 10. So our common group is 3x minus 10, and our other group is x plus 3. So 3x minus 10 equal to 0 would give us 3x is equal to 10. X equals 10 thirds. X plus 3 equal to 0 gives us x equals negative 3. So there are vertical asymptotes at 10 thirds and negative 3. Good? Okay, anyone not ready for me to change? Have you got it?
Yeah, we got it.
Okay. Let's do number 11. This one you want horizontal asymptotes. So we have f of x equals 5x to the 4th plus 3 over 2x to the 4th minus 5.
Can you split that down just a
So,
tad?
I sure can, I'm sorry. 5x to the 4th plus 3 over 2x to the 4th minus 5. Chandra, is that fuzzy for you, or can you see those numbers?
I can see it. It was just the top part was cut off.
Okay. So the m looks like 4, doesn't it? And the n is 4. So the m is equal to the n. So what do we do for our horizontal asymptote if m is equal to n?
Y equals A over B.
Well, what is a and b then?
5 and 2.
5 and 2. So y equals 5 over 2 is our horizontal asymptote. Okay,
Because it's the coefficients, right?
it's the coefficients. Very good terminology.
I had to remember it because I was like, why are we just doing 5 over 2?
Good.
And then I was like, oh, okay. Coefficient.
Okay. 12 is horizontal asymptote. This one's f of x equals x squared minus 7 over 7x to the 4th plus 6. So the m is 2 and the n is 4. So m is less than n. What do we do when m is less than n?
Y equals 0.
Yep. That's it. Okay, there's one more of these. Horizontal asymptote. So we have x cubed minus 3x squared plus x minus 2 in the top and x squared minus 11 in the bottom. Let's see, m is 3. N equals 2. So m is greater than n. So what do we do on that one?
There's no horizontal.
No horizontal. And it didn't ask us to find the oblique. If we're going to find it, we'd divide x squared into x cubed. And it looks like it would be an x up there. Y equals x. But it didn't ask for that. Okay, guys, it's time for us to stop. Do you have any questions? There, it goes to